This video is about solving one-step inequalities, okay? So you should have just gotten finished solving equations, and solving inequalities is just like solving equations, but there is one major exception, okay? If you multiply or divide both sides of the inequality by a negative value, the inequality symbol must reverse or flip, okay? And there's thousands of proofs out there to show why this is the case. I'm not going to go through that here, okay? I've got 5 different examples that cover just a little bit of everything that you might see when you're solving one-step inequalities. So, first one, x plus 9 is less than 11. All right, so we want to get x by itself. We're going to use inverse operations. So we've got x plus 9. We want to do the opposite of this addition of 9, and we want to subtract 9 from both sides. Okay? When you do that, on the left side, the 9's cancel out. Okay? And we're left with x is less than 2. Okay? Notice, we didn't multiply or divide by a negative, so the inequality symbol stays the same, okay? Now, you want to be able to graph this on a number line. X is less than 2 means that x could be 1, x could be 0, x could be any negative number. It can't be 2, and it can't be anything bigger than 2, okay? So on a number line, you're going to plot the point. This is an open circle. I know it's small and it's hard to see, but there's an open circle there because 2 is not included in the solution set. But notice, everything in red would be considered a solution. Okay, so open circle over the 2, everything to the left would be considered a solution. All right, example 2, x minus 5 is greater than or equal to negative 21. Okay, we want to use inverse operations. We're going to add 5 to both sides. Okay, on the left, the 5's cancel out. And that leaves me with my answer, x is greater than or equal to negative 16. Okay, what this solution means, x is bigger than negative 16. Every value that's bigger than negative 16 would be a solution. This little line right here means or equal to. So x is bigger than negative 16, or it can be equal to negative 16. So when you graph this on a number line, you're going to have a closed circle here. Again, I know that's hard to see. This circle is closed, okay? And every value to the right of negative 16 would be a solution, okay? Let's move on to the next one. Negative 5x is greater than 40. Okay, I want to get x by itself, so again, use inverse operations. This means negative 5 times x. The inverse of multiplication is division. So I want to divide both sides by negative 5. Okay, when I do that on the left side, the negative 5's cancel out. I divided by a negative on both sides. So that means this inequality symbol has to flip from greater than to less than in my answer. So x is going to be less than negative 8. Okay, when I plot that on the number line, I'm going to have an open circle. Again, I know that's hard to see, but there's an open circle there on the negative 8. Less than means to the left, so this would be the graph of my solution on a number line. Okay, 2 more examples. 8 times x is less than or equal to negative 64. I want to divide both sides by 8 to get x by itself. On the left, the 8's cancel out. I'm dividing by a positive, so the inequality symbol stays the same. X is less than or equal to negative 8. Okay, let's plot that on a number line. Closed circle over the negative 8 here. Okay, less than means we're going to the left. Okay, and finally, we've got a fraction here. 1/2 times x is greater than or equal to 2. Okay, in order, if you've got a fraction as a coefficient, you want to multiply by the reciprocal. That continues to be a one-step problem. We can multiply by the reciprocal. The reciprocal of a half is 2. So we want to multiply both sides by 2 to get x by itself. And here's how you show that step. Okay, so 2 times 1/2 x is greater than or equal to this 2 times this 2. Okay, we're multiplying by a positive, so notice the inequality symbol stays the same. Okay, those 2's cancel out. That leaves me with 1x on the left side, which is what I'm trying to achieve, is greater than or equal to 4. Okay. When I plot that on the number line, I've got a closed circle. There's a closed circle there over the 4. Greater than means to the right of 4. And that's how you solve one-step inequalities.